Hi guys, here's the video going over your spring final exam review. Just a couple pieces of information about your final exam. It's 30 questions and it is multiple choice. Your final exam review is not multiple choice, so I'll kind of give you a little bit of hints and some calculator tricks as we are working through your final exam review. So let's look at the first problem. So the first problem goes back to what you did with regression. So it says a box containing 1,000 coins is shaken and the coins are emptied onto a table. Only the coins that land heads up are returned to the box, and then the process is repeated. The table shows the number of trials and the number of coins returned to the box after each trial. What type of function would best model this table? Linear, quadratic, exponential, or logarithmic? Use mathematics to support your answer. So what you're going to do is you're going to put this in your calculator. So here are your keystrokes. You're going to start by hitting Stat, and then you are going to select Edit. Stat, Edit. And then for your table, the number of trials is going to go into L1. Coins returned is going to go into L2. So let me clear out my calculator. So I have 0, 0, 1, 3, 4, and 6 in my L1. L2 is 1,000, 610, 220, 132, and 45. So once I have that data in my calculator, I'm going to fix that D and edit. It's really bothering me. There you go. Once I have those two sets of data in my calculator, what you're going to do is you're going to hit Stat again, except this time you're going to move over to Calc. So Stat, Calc. So what you're doing is you're selecting linear, quadratic, exponential, and logarithmic regression. So the linear regression is the 4, looks like this. So I'm going to go ahead and select that. I'm going to go down to Calculate, and I get my equation. Now what you're looking for is you are looking for the r squared value. And the r squared value is going to tell you which of those functions is the one that best models the data. Now if your r squared value does not show up, then that means there's something in your mode that you have to fix. So what you're looking for in the mode is you're looking for stat diagnostics. And you just need to make sure that this is turned on. And once it is turned on, you will see the r squared values. So for instance, for linear regression, my r squared value was 0.87. I'm going to do the same thing for quadratic, so I'm going to hit Stat, move over to Calc, except I'm going to select quadratic regression, which is number 5. It says quad reg. I'm going to hit Calculate, look for that r squared value again, and your r squared value for this is 0.99. I'm going to do the same thing for exponential and logarithmic. So Stat, Calc, exponential is 0. So that's the one that says EXP, REG. So I'm going to select that. Go down to Calculate. R squared is 0.9997. Now, since my r squared value for exponential was 0.99, just like my quadratic regression was 0.99, I'm going to look at my quadratic regression again and go to more decimal places so we can compare the two. So let me do, whoops, oh Lord, keep messing up on my calculator. Let me do quadratic regression again, and that gives me 0.9936. And then the last one we want to do is linear regression. So Stat Calc, logarithmic regression. That's number 9. Or it says ln regression because it's natural log. I'm going to select that, and it gives me an error. So the error means that the logarithmic function wouldn't work at all. So what you're trying to do is you're trying to compare your r squares, and the one that has an r squared that's closest to 1 is the function that would best model the data. So in this case, our exponential function was the one that was closest to 1, so we would select exponential. Alright, let's go to the next problem. So for the next problem, we're converting radians, so 100 degrees. I'm going to multiply this by pi over 180. So 100, so it becomes 100 pi over 180. So I just need to reduce the 100 over 180. That gives me 5 pi over 9. For 330 degrees, again, multiplying by pi over 180. So 330 divided by 180, just want to reduce that. That gives me 11 pi over 6. Okay. For number 3, you can do this a couple different ways. You can do the hand trick. So the hand trick for sine of 60 degrees is your index finger. So I'm going to put down my index finger, and that gives me root 3 over 2, since sine is your y coordinate. For tangent of 30 degrees is your index finger, and with tangent, you're always looking at the back of your hand instead of the palm of your hand. And so that equals 1 over root 3, which I can rationalize to root 3 over 3. For cosine of 135 is in the second quadrant. It's over here where cosine is negative. The reference angle is 45 degrees. So cosine of 45 degrees is root 2 over 2 because you're putting down your middle finger. But if we're in that second quadrant over here, cosine's negative. So that becomes negative root 2 over 2. And then cosecant is the reciprocal of sine. So I want to start by finding sine of 135 degrees first. Again, you can use the hand trick. 135 is in that second quadrant. Sine is my y-coordinate. So my y-coordinate in the second quadrant is positive, and it's positive root 2 over 2. So that means cosecant is going to be the reciprocal of this. So from here, I do need to flip it over. So that's 2 over root 2, rationalize it. So that's 2 root 2 over 2, which is just root 2. Now, there is a way that you can do these in the calculator. What you have to do is you just have to associate the decimals with the radicals. So for example, root 3 over 2 is 0.866. So if I take sine of 60 degrees in my calculator, it gives me 0.866, so that's root 3 over 2. Now, with tangents and the cosecants, I would look at, well, with tangent, there's really 3 values that you can have for tangent. You can have 1 or negative 1. You could have root 3 over 3, or you could have root 3. So let me write this down. So tangent is 1, root 3, or root 3 over 3. So you can test out these decimals and see which one matches. So for example, if I do tangent of 33 in my calculator, that gives me 0.577. And then I'm just going to take the square root of 3, see what that is. Well, the square root of 3 is 1.73, so that's not 0.577. So the square root of 3 divided by 3 is 0.577. So then I know it's root 3 over 3. For the cosecant, I would find sine first. So then sine is the y-coordinate at 135. So I can type in my calculator sine of 135. And then I know 0.707 is root 2 over 2. And then from there, you're just taking that root 2 over 2 and flipping it over. So you can use the calculators as long as you know what decimals associate with what radicals. All right, reference angles, you just draw the angles in the particular quadrant. So in this case, 57 degrees is in that first quadrant, which makes your reference angle 57 degrees. 123 is in the second quadrant. This right here is your reference angle. So to find that angle, I'm going to take 180 minus 123, which is 57 degrees. 252 is in this third quadrant. This is your reference angle. So I'm going to take 252 minus 180. So your reference angle is 72 degrees. Would have been funny if that was another 57, since the first two were 57s. I should change the review in the future to make them all 57s, just for fun. For letter D, 359 degrees is over here. This is your reference angle. So 360 minus 351 is 1 degree. So your reference angle is always this little wedge that's resting up against the x-axis. For number 5, you're finding the missing side. So it says leave your answers as radicals in simplest form. So there's a couple ways that you can do this. If you've memorized the special right triangles, it's the fastest way to go. If you don't know the special right triangles, then you can use SOHCAHTOA. I like the special right triangle since I remember it. So for my special right triangles, it's a 45, 45, 90 triangle. So this side right here is A, 1A, 1A, and then the hypotenuse is root 2A. So since I know this side, I can take 4 and set it equal to root 2A and use that to solve for A. So I'm going to divide both sides by root 2. This I need to rationalize, so that becomes 4 root 2 over 2. And then 4 over 2 reduces, so A equals 2 root 2. So now that I've solved for A, x is equal to 1a, so that means x equals 2 root 2. Y is equal to 1a as well, so y also equals 2 root 2. And those are the two sides. For letter B, it's a 30, 60, 90 triangle. Across from the 30 degrees is 1a, across from the 90 degrees is 2a, and across from the 60 degrees is the square root of 3a. Now since I know this side, I know that 1a equals 2, so a equals 2. So for u is 2 times a, so 2 times 2 is 4. For v is the square root of 3 times a, so the square root of 3 times 2 is 2 root 3. And then those are your two sides of that triangle. For number 6, I am giving you one of the trig functions, and I'm also giving you that cosine of theta is less than 0, and I want you to find sine of theta. For these, you need to draw a triangle. So tangent is negative 1/5, so that's my opposite and my adjacent. So don't forget about SOHCAHTOA. I would write that down. Make sure you spell it correctly, otherwise it defeats the purpose. So opposite over adjacent. And what's happening is my tangent is negative and my cosine is also negative. So I need to figure out what quadrant I'm in. There's a couple ways that you can do that. You can look at ordered pairs, or you can look at this, the ASTC. All students take calculus, or some people say all students take crack, whatever floats your boat and lets you remember. So what this tells you is this tells you where your trig functions are positive. And the way that you can remember that it's positive is if you look at your x-axis and your y-axis, it looks like a plus sign, right? So positive. So in the first quadrant, all trig functions are positive. In the second quadrant, sine is positive. Third quadrant, tangent's positive. And in your fourth quadrant, cosine is positive. So I'm looking for a quadrant that has a negative tangent as well as a negative cosine. So cosine is negative in these two, since it's positive over here. So cosine's negative in these two, but tangent's positive in this quadrant, so that means your triangle is going to be in the second quadrant. So I'm going to go ahead and draw my triangle in the second quadrant. It's a right triangle. It says opposite over adjacent, so my opposite side from theta, here's your theta, opposite is 1, adjacent is 5. Now one of those values is negative because it was a negative 1/5. So if I look at this triangle, my horizontal distance is negative because you're with the negative x's, vertical distance is positive, so the negative is with the 5. Now I can use the Pythagorean theorem to figure out the hypotenuse, so 1 squared plus negative 5 squared and square root. That gives me the square root of 26. So I need all three sides for the triangle to be able to figure out my final answer, which what I'm looking for is sine of theta. So now I have sine of theta equals opposite over hypotenuse. My opposite side is 1. My hypotenuse is root 26. And of course we don't like radicals in the denominator, so let's rationalize it. So that's root 26 over 26. For letter B, I'm going to do the same thing. So sine is positive and tangent's also positive, so I need both of those to be positive. So sine is positive in these two quadrants, tangent's positive in these two quadrants, so the overlap is that first quadrant. So I'm going to draw my triangle in the first quadrant. So sine is opposite over hypotenuse. So my opposite side of theta is 5, hypotenuse is 13. Your other leg, if you use the Pythagorean theorem, is going to be 12. It's also a Pythagorean triple, so if you remember 12 or 5, 12, 13, that's helpful. Now I'm trying to find secant. So secant is the reciprocal of cosine, so I'm going to find cosine first. Cosine's adjacent over hypotenuse, so 12/13. And secant is the reciprocal of that, so that is 13/12. And that's your final answer for letter B. All right, number 7, amplitude and period. So amplitude is the number that's in front of your trig function, and to find period, it is 2 pi divided by b. So I have my amplitude, which is the number in front, positive, because amplitude is always positive, and the period is 2 pi divided by b. b is the number in front of x. So in this case, it's 2 pi divided by 3. So that can't be reduced, so you're done. Your amplitude for letter B is 2. For the period, it's 2 pi divided by 1/2. 2 pi divided by 1/2 is 4 pi. So there's your amplitude and period. Now let's say I give you a tangent function. Tangent has no amplitude. And if you're trying to find the period for tangent, it's pi divided by b instead of 2 pi divided by b like it is for sine and cosine. All right, number 8. Find the equation of the cosine and sine function in the form y equals a cosine bx plus c, and y equals a sine of bx plus c. So there's a couple things that I need to find. I need to find my amplitude, I need to find the period, and I need to find phase shifts. So we have to find the amplitude first. So your amplitude is how high or how low your graph is going to go. So if you look at letter A, our amplitude is, or our graph goes from 3 to -3. Sorry. So my amplitude is 3. For the period, what I'm looking for is I'm looking for 1 cycle of cosine or 1 cycle of sine. I like to look for 1 cycle of sine just because I like the sine function. So sine starts at the midline and goes up. So this right here is a sine function. So for the period, what I'm looking for is I'm looking for what this distance is. So I'm going from negative pi over 3 to a positive pi over 3. So that distance is 2 pi over 3. So the period is 2 pi over 3. Now what the period does is that it helps us find b. So now that I have the period as 2 pi over 3, I can set that equal to b. Sorry, I can, oh, Lord. 2 pi over 3, set that equal to 2 pi over b, and I can use that to solve for b. So b in this case is 3. And why do I need b? It's because it's part of the formula up here, because it's the number in front of your x. So I have my amplitude and I have b. What I'm looking for next is I'm looking for a phase shift. So your phase shifts are where your graph has moved from its original position. So sine usually starts at the origin and goes up and does something like this. But now we have a phase shift, so I'm looking for the one that's directly to the left of my y-axis. So that's this one right here. So here's my sine function. So normally it starts at the origin, but now it's starting over here. So that's my phase shift. So my phase shift for this is negative pi over 3 for sine. So I'm going to write my sine phase shift is negative pi over 3. My cosine phase shift, well typically cosine starts at your positive amplitude and then goes down and back up. Looks like a little V. But instead of starting on your y-axis, my first cycle of cosine starts right here and then creates the V. So that's halfway between 0 and negative pi over 3. So my phase shift is going to be negative pi over 6. So my cosine phase shift is negative pi over 6. Now on your final exam, you're not going to have to do both sine and cosine. It'll just be one or the other, but just wanted to do both so you have that practice. So now I'm going to write the equation. So my equation for sine is y equals, just following what it says in the directions, a sine. So my a was my amplitude, so 3 sine of bx. So b was 3. And then x plus cc is your phase shift. So it becomes x plus pi over 3, because it's always the opposite when you put the phase shift in. And then to get your equation in final form, I need to distribute this 3. So I have 3 sine of 3x plus pi, because 3 times pi over 3 is just pi. So here's your equation for sine. For cosine, I have y equals my amplitude, cosine of bx, so that's 3, times x plus my phase shift, because your phase shift is always the opposite when it gets put in the equation. I have to distribute the 3, so y equals 3 cosine of 3x. And then 3 times pi over 6 is going to be 3 pi over 6, which is pi over 2. And this is your equation for cosine. Now for the next problem, letter B, I'm not going to do the entire problem. I'm just going to find the important pieces for you, and then you can write the equations yourself. So I need to find my amplitude. Your graph goes up to 2 and down to negative 2, so my amplitude is 2. The period, so I'm looking for one cycle of sine or one cycle of cosine. So let's look for one cycle of cosine just to add some variety. So cosine goes from peak to peak. So I'm going from here to here. I need to figure out what this distance is, and that's the period. So I'm going from negative 4 pi to 0, so the period is 4 pi. So again, the period, we use that to find b. So 4 pi equals 2 pi over b. I'm going to cross multiply, so 4 pi b equals 2 pi. Divide by 4 pi, so b equals 1/2. So I have my amplitude, I have b. The last thing you need are your phase shifts. So I'm going to start by looking for cosine. So cosine typically starts at your peak and then creates a V, which is exactly what we have for this graph. So that means cosine does not have a phase shift, so your cosine phase shift is 0. Now let's look for sine. So sine typically starts at the origin and then creates a nice curve like this. But instead of starting at the origin, starting right here, and then making your curve. So this distance is negative pi. So my sine phase shift is negative pi. And then now that you have your phase shifts, you can go ahead and write the equations the same exact way that we did for letter A. Alright, evaluate the following in radians. What I would recommend doing is using the calculator and starting it in degrees and then just converting to radians. So in my calculator, I'm going to type this in exactly how it looks. So I'm taking the inverse tangent of negative 1, and the calculator gives me negative 45 degrees. Now what I want to do is just convert that to radians. So negative 45, I'm going to divide that by 180. That gives me negative 1/4. So my angle in radians, sorry, I cannot stop yawning. So excuse me while I yawn while I make your video. So that's negative pi over 4. I had a Coke Zero, but I think the caffeine is wearing off. Arc sine is the same thing as inverse sine, so that's the same thing as this. So I'm going to type that into my calculator, and that gives me negative 60 degrees, which I can then convert to radians, which is negative pi over 3. And then I can do the same thing with the inverse cosine. Calculator gives me 60 degrees, convert that to radians. So that is positive pi over 3. So use the calculator. Just make sure your calculator is in degree mode, and then just convert it to radians. That's the easy way to go. Alright, so two 100-foot guy wires are attached to the top of a telephone pole, one on each side. The angle of elevation to each wire with the ground is 57 degrees. How tall is a telephone pole to the nearest foot? So I'm going to start by drawing my telephone pole. The guy wires are just the wires that are connected to the top of the telephone pole. Mr. Rupp really likes guy wire problems. That's why we always have them. But I had no idea for the longest time what a guy wire was. But, you know, you learn something new every day. So my angle of elevation is 57 degrees, so that means from the horizontal up is 57 degrees. I do know that the guy wires are 100 feet. So I know that distance is 100, and what I'm looking for is I'm looking for the height of the telephone pole. So I'm looking for this. So I'm just going to focus on this one right triangle, since I do have two right triangles. But if you look at what you have, from this angle, I have my opposite side and my hypotenuse. So I'm asking myself, which trig function uses opposite and hypotenuse? That is sine. So I have sine of theta, so sine of 57 degrees equals opposite over hypotenuse. I can go ahead and multiply both sides by 100, so I get x equals 100 sine of 57 degrees, and then plug that into my calculator, and I get 84 feet. And there's your answer. From a 75-foot observation tower on the coast, a Coast Guard officer sights a boat in difficulty. The board is 625 feet away from the base of a tower. The board. I think that's supposed to say boat. I got confused for a second. That should say boat. Find the angle of depression from the top of the tower to the boat to the nearest degree. Alright, so you have this tower. You got this guy hanging out on top of the tower. He spots a boat and a person on a boat. Here's the boat. Here's the person. Person's yelling, help me, save me from the ocean. And that boat is 625 feet away from the Coast Guard tower. What else do I know? I know the tower is 75 feet, so this distance. I'm writing this sideways, that's why it's going so slow. So that distance is 75 feet. I need to find the angle of depression from the top of the tower to the boat. So my angle of depression is this angle right here, because angles of depression are always from the horizontal. down. So this is the theta that I'm solving for. Now, since the height of my tower is 75 feet, that makes this height 75 feet as well. And since the distance is 625 on the bottom, that makes this distance also 625 feet. So if I look at my angle, I have my opposite side and my adjacent side. So my trig function that I'm going to use is tangent. Since I am solving for an angle, I'm using the inverse tangent. So it's the inverse tangent of 75 over 625, which I'm going to plug into the calculator, and that gives me 7 degrees. Alright, the point 3, -7 lies on the terminal side of angle theta. Find all 6 trig ratios, sine, cosine, tangent, cosecant, secant, cotangent. So let's go ahead and start by plotting this point. So 3, -7 would put you in the 4th quadrant. I can use, oh, it looks weird. I can use the Pythagorean theorem to solve for that hypotenuse, and it ends up being the square root of 58. And here's my theta. So I want to find all 6 trig ratios, so I'm going to start by doing sine, cosine, and tangent. So sine of theta is opposite over hypotenuse, which is -7 over the square root of 58, which we need to rationalize, so it's -7 root 58 over 58. Cosine of theta is adjacent over hypotenuse, so that's 3 over root 58. So that's 3 root 58 over 58. Tangent of theta is opposite over adjacent, so that's -7 over 3. So now that I have sine, cosine, and tangent, I can find cosecant, secant, and cotangent fairly quickly. So cosecant is the reciprocal of sine, so I'm going to take sine and flip it over. I'm not going to flip this one over because that's going to put radicals back in the denominator. I'm going to go ahead and flip this one over. So that becomes negative root 58 over 7. I'm going to do the same thing for cosine. The reciprocal of cosine is secant. So secant of theta is going to be root 58 over 3. And then cotangent is going to be -3/7. So that gives you all 6 trig ratios. Alright, so 13 and 14 goes back to what we did with identities. So number 13 says to factor and simplify. So I'm going to look at what these two have in common. And I have tangent squares in both of them, so I'm going to start by factoring out the tangent squared. When I do that, that leaves me with 1 minus sine squared. Now, if I look at my reference sheet of all the trig functions, 1 minus sine squared, oh, that's an x. 1 minus sine squared is the same thing as cosine squared. Why do I keep writing thetas? So that's cosine squared of x. Now that can be simplified further because sine squared, or tangent squared, is the same thing as sine squared over cosine squared, and I'm multiplying that by cosine squared. Now if you'll notice, your cosine squares cancel, so that means your final answer is sine squared of x. For number 14, I'm going to do the same thing. So cosecant is 1 over sine, and then cotangent is cosine over sine. Now this looks weird because you have a fraction and a fraction, so I'm going to multiply by the reciprocal. So I have 1 over sine, and I'm going to take that bottom fraction and flip it over. So that becomes sine of x over cosine of x. And then my sines cancel. So I have 1 over cosine of x. Sorry, 1 over cosine of x is secant of x. And then it's simplified. Alright, finding solution. So we want to isolate the trig function first. So I'm going to add 1 and divide by 4. So that leaves me with cosine squared theta, or x. equals 1/4. I'm going to take the square root, so cosine of x equals plus or minus 1/2. Now since it's plus or minus, you are in all four quadrants, because cosine's positive in the first, second, third, and fourth quadrant. So I'm going to go to my hand trick. I need to figure out which finger do I put down to get my x-coordinate be 1/2, and that's my index finger. And my index finger corresponds to pi over 3. So my first angle is pi over 3. So this is pi over 3, this is pi over 3, that's pi over 3, and that is pi over 3. All my angles have to be from standard position though. So over here is pi. Pi in thirds is 3 pi over 3. And over here is 2 pi. 2 pi in thirds is 6 pi over 3. So for my second angle, I'm going from here to here. That's going to be taking away pi over 3 from 3 pi over 3. So that angle is 2 pi over 3. For my third angle, I'm going from here to here. So that's 3 pi over 3 plus the extra pi over 3. So that's 4 pi over 3. And my last angle is going to be pi over 3 taken away from 6 pi over 3. So that's 5 pi over 3. And there are your 4 answers for that problem. 16, finding all the solutions. I want to isolate the sine function, so I have sine of x equals root 3 over 2. So I need to figure out what angles give me a positive root 3 over 2 for sine. So sine's positive in these two quadrants. So I need to find that reference angle. So I'm going to start putting down fingers until my y-coordinate is root 3 over 2, and then that ends up being the index finger again. So this angle right here is root 3 over 2, and this angle right here is, I didn't mean to say root 3 over 2. This angle is pi over 2, and this angle is also pi over 2. So my first solution is, not pi over 2, pi over 3, sorry. So my first solution is pi over 3, and my second angle is 2 pi over 3. Now since we're solving for all solutions, because that's what the direction says, I'm going to take those two answers and just add 2 pi n to them. That allows us to find all of the infinite answers that you could have for that solution. Alright. Find the exact values of sine of 2u, cosine of 2u given for the given values of u. I'm not going to do both of these because that gets repetitive. So I'm just going to do the first one. So for the first one, my angle is between 0 and pi over 2. So when I draw my triangle, I'm going to be in that first quadrant. Cosine is not opposite over hypotenuse. It is adjacent over hypotenuse. So my adjacent side is 3, my hypotenuse is 5, it's a Pythagorean triple, that makes this side 4. Now I'm trying to find sine of 2u and cosine of 2u, so I can look on my formula sheet for sine of 2u. Sine of 2u is equal to 2 sine u cosine u. So sine of u, if I look at my triangle, is 4/5. Cosine of u is 3/5. And I'm taking that and multiplying it by 2. So I can take that and plug it into my calculator. That gives me 24/25. For cosine of 2u, you have 3 formulas to choose from. It doesn't matter which one you pick. I'm going to pick the third one, where it says 2 cosine squared u minus 1. I actually don't know if it's the third one or not because I don't have the formula sheet in front of me. I just assumed it was the third one. But 2 cosine squared of u, cosine squared of 3/5. Oh, Lord. minus 1. So I can take that and plug it right into my calculator, and that gives me negative 7/25. So there's your two answers for letter A. Like I said, I'm not going to do letter B because, you know, it's the same thing. Draw your triangle. This one you're in the second quadrant. All right. Moving forward. So 18, given a triangle with sides A equals 6, B equals 8, and C equals 12, find angle C to the nearest degree. So let's go ahead and draw this triangle first so you can see what we're dealing with. Just drawing a generic triangle. I usually don't pay attention to where I put my angles. So across from angle A is side A, which is 6. Across from B is B, and across from C is C. What I'm looking for is angle C. Now I have all three sides of the triangle, which means I'm going to use the law of cosines. So since I'm trying to find angle C, my side C is what's going to start off the formula. So it's 12 squared, 12 squared equals my other two sides squared, so 6 squared plus 8 squared, minus 2 times your other two sides, cosine of my angle, which is C, and that's what I'm trying to find. So 12 squared is 144. 6 squared plus 8 squared is 100. 2 times 6 times 8 is 96. Cosine of C. I can subtract 100 from both sides. That gives me 44 equals negative 96. Cosine of C. Divide both sides by negative 96, and then I have negative 0.4583 equals cosine of C. And then to find the angle, you're just going to do the inverse cosine. So when I take the inverse cosine of this, theta equals 117 degrees. All right, for 19, let me draw my triangle. So angle A is 115. Obviously this triangle is not drawn to scale. Side B is 15. Side C is 10. Now if you look at what you have side angle side, which means you have to use the law of cosines. For a law of sines, you would have to have an angle in its corresponding side, which we don't have. We're trying to find side A. So since I know angle A, I'm going to use side A to start off the formula, and angle A is going to end off the formula for law of cosines. So I have A squared equals my other two sides squared, so 10 squared plus 15 squared, minus 2 times my other two sides, cosine of my angle. So I can plug all of that into my calculator and then take the square root, and you should get A equals 21.3. Alright, so I have a third triangle, A, B, C. A is 82 degrees, side A is 4, C is 53 degrees, and I want to find side C. So if you look at this one, I do have an angle on its corresponding side because I have A and A. So that means I can use the law of sines. So I have sine of 82 over 4 equals sine of 53 degrees over side C. Just work through that cross multiplication and you should end up with C is about 3.2. Word problems. So the angle at one corner of a triangular plot of ground is 73.6 degrees, and the sides that meet at this corner are 75 feet and 100 feet long. Approximate the length of the third side. So I have a triangular plot of land. The angle at one corner is 73.6 degrees. And the sides that meet this corner are 75 feet and 100 feet long. 175. So this is 175, and this is 150. Not degrees. Approximate the length of the third side. So I have side angle side, so that means I'm going to do the law of cosines again. So let's just call this x. So I have x squared equals my other two sides squared, so 175 squared plus 150 squared minus 2 times 175 times 150, I think I'm running out of space, cosine of my angle, which was 73.6 degrees. I'm going to take that and plug it right into my calculator, take the square root, and you end up with approximately 195.7. And don't forget your units, it is in feet. Alright, two cars leave a city at the same time, traveling along straight highways that differ in a direction by 84 degrees. So they're going along straight highways that differ in directions by 84 degrees. So that means the angle in between the two highways is 84 degrees. If their speeds are 60 miles per hour and 45 miles per hour respectively, approximately how far are the cars at the end of 20 minutes? So the first thing I need to do is I need to convert 20 minutes to hours, because my rate for the speed is in terms of hours. So 20 minutes is equivalent to 1/3 of an hour, right? Because an hour is 60 minutes, so 20 divided by 60 is 1/3. So to actually figure out the distances, if I know that this person's going 60 miles per hour for 1/3 of an hour, that means this person has traveled 20 miles. I can do the same thing for the 45 miles per hour. So this person's going 45 miles per hour for 1/3 of an hour, so that means this person is going 15 miles. So now I have two side lengths and the angle in between. I want to figure out how far apart they are, so I'm trying to figure this out. So I'm going to call this x. So it is a law of cosines problem. So I have x squared equals my other two sides squared, so 15 squared plus 20 squared minus 2 times my other two sides, cosine of my angle. Plug that into the calculator, take the square root, and it is approximately 23.7 miles. Two people spot an air balloon. For some reason I kept wanting to say hot air balloon, and doesn't make sense with hot air balloon. Anyway, they are 8.4 miles apart, and the air balloon is between their locations. The angles of elevations to the air balloons for each person are 24 and 47 degrees respectively. How far is the air balloon from each person? So here is person number 1, person number 2, and there is a hot air balloon in between them. There we go, hot air balloon. So the angle of elevations are 24 degrees and 47 degrees. What else do I know? They are 8.4 miles apart. I want to find these two distances. I want to find this and this. So I'm going to label it as x and y. I'm actually just going to find one of them, and you can find the other one because the process is the same for both. I can find this third angle, since all angles in a triangle add up to 180, so that third angle ends up being 109 degrees. I'm going to go ahead and find x. X is opposite the 47 degrees, so I have sine of 47 over x equals sine of 109 over 8.4. I can cross multiply and solve for x, and that ends up being, 6.5 miles. You can also solve for y using that same method, and y ends up being 3.6 miles. Alright, 24. Find the magnitude and the direction of the vector. So you just took a test on this, so hopefully you know what you're doing. So my magnitude of A is the square root of my horizontal component squared plus my vertical component squared. And when I do that, I get 6. For the direction, you need to draw the vector, so that ends up being in that third quadrant, where my horizontal component is 3, vertical component is negative root 3, and there's my theta. To find theta, that's just going to be the inverse tangent of negative 3 root 3 over 3. I can plug that into my calculator, and it gives me negative 60. So the angle we want is in standard position, so going from the positive x-axis until you hit that vector, so that's going to be 30 degrees. 300 degrees. And then 300 degrees in radians, just in case the answer needs to be in radians, because this one doesn't really specify. That's 5 pi over 3. So I think either of those would work. It just depends on how the answers are listed since it's multiple choice. All right. Find the smallest positive angle theta from the positive x-axis to the given vector. Round to the nearest tenth if necessary. So this is just finding the direction. So I'm going to go ahead and graph my vector. I'm actually going to skip A and do B because I don't feel like doing both of them. You can do the other one. So when I graph my vector, that's negative 3 for my horizontal component, positive 4 for my vertical component, and here's my theta. So again, I'm going to do the inverse tangent because everything goes back to tangent. So opposite over adjacent. And my calculator gives me negative 53.1 degrees. Now keep in mind my angle has to be from standard position, so here to here. So I'm going 53.1 degrees less than hitting 180 degrees. So I'm going to take 180 minus 53.1, and then my angle is 126.9 degrees. And it says round to the nearest tenth if necessary, so I'm assuming that they just want that in degrees instead of radians. Alright, find the dot product and the angle in between the two vectors. So for the dot product, I'm multiplying my corresponding components together. So A dot B, that is going to be 3 times negative 4, which is negative 12, plus negative 2 times 8, so negative 16, which is negative 28. So when I ask for the dot product, it's negative 28. For the angle in between, you need to know 3 things. You need to know the dot product and the 2 magnitudes. So I'm going to go ahead and find the magnitude of A. That's the square root of 3 squared plus negative 2 squared, which is 13. And I'm going to find the magnitude of B. So that's the square root of negative 4 squared plus 8 squared. And that's the square root of 80. So for the angle in between, it is cosine of theta equals my dot product over the product of my 2 magnitudes. So I can take that and put it into my calculator, and then I'm going to do the inverse cosine since I'm solving for an angle, and that gives you 150.3 degrees. Alright, rewrite the following in trigonometric form. I'm only going to do one of these because, like I said, it gets repetitive. But if you wanted to graph negative 3 is the same thing as negative 3 plus 0i. Just a little hint. I'm going to go ahead and do letter B. So there's 2 things you need to know for trig form. You need to know your r and you need to know theta. So that's the same thing as direction and magnitude. So r is the same thing as finding magnitude. So that's negative 2 squared plus negative 2 root 3 squared. And then my r ends up equaling 4. To find theta, I'm going to graph this. So negative 2 root 3, negative 2, negative 2 root 3. So that puts you in that third quadrant. Anytime we're finding theta, we're always using inverse tangent. So that's negative 2 root 3 over negative 2. If I plug that into my calculator, that gives me 240 degrees. which usually for trig form we write that in radians. So that in radians is 4 pi over 3. So my final answer in trig form is r cosine I sine of theta. So my r is 4 cis of 4 pi over 3. And there is your trig form. For de Moivre's theorem, let's see, it's already in trig form, so then you're just going to follow de Moivre's theorem, which states that you have your r to the nth power cosine I sine of n theta. So lucky for you, I've already given you r and theta, which is not what it was like on your chapter 6 test. But I have 2 to the 6th cosine I sine, cosine I sine of 6 times theta. And n is your exponent, so 6 times 300. So that gives me 2 to the 6th is 64 cosine I sine of 1800 degrees. So I need to take 64 times cosine of 1800 is 1, plus I sine of 1800 is going to be 0i. And when I distribute that, that just gives me 64. Alright, so your final answer for that is 64. Alright, 29, write a formula for the nth term of the sequence. So let's start by establishing the pattern. Your pattern is you are adding 3 every single time. So my first term is 2. My common difference is 3. So writing the formula for the nth term means you are using the arithmetic sequence formula. So I have 2 plus n minus 1 times 3. I can distribute the 3, so that's 2 plus 3n minus 3. Combine like terms, and you get an equals negative 1 plus 3n. And that's your formula for the sequence. Find the 83rd term of the arithmetic sequence where your first term is 1.8 and your common difference is 24. You're just going to plug that into the formula. So my first term was 1.8 plus n minus 1 times my common difference. I can take that and plug it into my calculator, and that's 198.6. Alright, find the sum. So this is the sigma notation. You can do this on the calculator, so let's do that instead. If you hit alpha window, it is number 2. So let me make a note. Alpha window. And this only works on TI-84s, by the way. So if you are one of those unfortunate souls that has a TI-83, I would just borrow a TI-84 for this particular problem. Once you hit alpha window, it's option number 2. You can type this into the calculator, exactly how it looks, and plug it in. So that gives you 64,000 for the first one, and then for the second one, you get a very large number, 3355443. That was a fun number. For letter B, when you are plugging this one into the calculator, just make sure this 3, negative 2 to the n minus 1 stays inside the parentheses that the calculator gives you to start with. And there are your 2 answers. These are good calculator questions. Alright, a runner begins training by running 5 miles 1 week. The second week she runs a total of 6.5 miles. The third week she runs 8 miles. Assume this pattern continues. How far will she run in the 10th week? So her first term of this sequence is that first week of running, which is 5 miles. The pattern is that she's adding 1.5 miles every week, so that makes it an arithmetic sequence. So my common difference is 1.5. So I want to figure out how far she will run in the 10th week, so I'm trying to find my 10th term. So my first term is 5 plus n minus 1 times my common difference. I can plug that into the calculator, so that's 18.5 miles. at the end of the 10th week, what will be the total distance she has run since she started training? So what we want to do is we want to add up all of the miles that she ran every single week. So what that is that's an arithmetic series. So there's a form for the arithmetic series. I know that it's for 10 weeks, so I know n. So it's 2 times your first term, and this should be on your formula sheet. N minus 1 times my common difference. And that equals 117.5 miles. A snail crawling straight up a wall. The first hour it climbs 16 inches, the second hour it climbs 12 inches, and each succeeding hour it climbs only 3/4 the distance it climbed in the previous hour. Assume this pattern continues. How far does the snail climb during the 7th hour? So this one is a geometric sequence since you're multiplying by 3/4 every time. So my first term is that first distance, which is 16 inches, and then my common ratio is 3/4. So if I'm trying to find how far the snail climbs in the 7th hour, that's my 7th term. So I'm just following the formula for a geometric sequence. So that's a1 times r to the n minus 1 power, and that gives you about 2.85 inches. All right, 34. How many possible groups can be formed by selecting 2 puppies out of 12? That is a combination, so that is 12, choose 2. You can plug that into the calculator. You can hit math, move over to prob, where it says probability, and then it's option number 3. Or if you hit alpha window, on some of the TI-84s, you'll have the options for the permutations, combinations, and factorials. But I can plug that into my calculator, and that gives me 66 groups. 35, find the number of distinguishable permutations using the letters in the word cabbage. So I can count up the letters in the word cabbage. There's 1, 2, 3, 4, 5, 6, 7. So the distinguishable permutation starts with 7 factorial, so that's how many letters you have. And then you look at each individual letter. So I have 1 C, so that's 1 factorial. I have 2 A's, so 2 factorial. I have 2 B's, so 2 factorial. 1 G, and then finally 1 E. So if I total up the numbers in the denominator, I have 1 plus 2 plus 2 plus 1 plus 1 is 7. So it should equal the same number in the numerator. And I can plug that into my calculator, so I get 1,260 distinguishable permutations. All right, find the 5th term of the expansion in each of the following. So for the 5th term, you need to remember a few patterns with, what was this called? The binomial theorem. So since I'm trying to find my 5th term, I need to figure out what my exponents are going to be. So for my 5th term, the bottom number of the choosing, actually hang on a second. I kind of forgot how to do this. Let's see. I can do this. Okay, so for my 5th term, for my first term, it would be 8, choose 0, and then I would have x squared to the 8th power, and then negative 3y to the 0th power. For the next term, the 2nd term, it would be 8, choose 1, x squared to the 7th power, and then negative 3y to the 1st power. So here are a couple patterns, here are a couple things we need to establish. So these two exponents should add up to this one. So 1 plus 7 is 8, 0 plus 8 is also 8. The other thing we need to establish is that the bottom of this choosing corresponds to that second exponent, so 0, 0, 1, and 1. So if this pattern continues, and I want to get to my fifth term, that's 8, choose 4. Because if you'll notice for my second term, it was choose 1, so it's 1 less than the term number. So 8, choose 4, so this denominator, it's not a denominator, the bottom number for the choosing matches up with that second exponent. And then for that first exponent, well, these two exponents have to add up to 8. So what plus 4 gives us 8? That's 4. I do remember how to do this. Okay, so I need to do 8 choose 4. So again, you can do that in the calculator. 8 choose 4 is, let me plug that in, 70. X squared to the 4th is x to the 8th. Negative 3 to the 4th is 81, y to the 4th. And then I can just multiply 70 and 81. So that's 5,670, x to the 8th, y to the 4th. And there's your answer for letter A. I'm going to go ahead and do letter B, since I kind of botched up letter A initially. So I'm trying to find the fifth term of the expansion. So that's going to be 7, choose 4. And then that bottom number is the same thing as the exponent for the second term. So this will be 3y squared to the 4th, 2x squared in the first parenthesis. And again, these two exponents have to add up to 7. So that makes this exponent 3. So I need to do the 7, choose 4. That gives me 35. 2 to the 3rd is 8. X squared cubed is x to the 6th. 3 to the 4th is 81. Y to the 8th. And then I can just multiply 35 times 8 times 81, and that gives me 2,206, oh, I read that wrong, 22,680 x to the, shoot, I did something wrong. Oh no. This x squared should be an x cubed. How come nobody told me? Oh wait, it's because nobody's in here and I'm talking to myself. That sounded a lot sadder than I wanted it to be. So that's supposed to be x to the 9th. Alright, there we go. And y to the 8th. Alright, almost done. Whew. So a card is drawn at random from a standard deck of 52 playing cards. Find the probability that the card is red, or king. So the number of reds in a deck of cards is 26 out of 52, also known as 1/2. The number of kings in a deck of cards is 4 out of 52, also known as 1/13. Red or king, so this is an or probability. So I can total up the number of reds that I have, plus the number of kings that I have. And then you have to ask yourself, do you have any red kings? You sure do. So, excuse me, so you need to subtract that. And that's all over 52. So that gives me 28 over 52, also known as 7/13. So the or probabilities, you have to subtract any sort of overlap that you have, which for letter C we had an overlap because we had a red king. A password is comprised, I was going to say compromised. A password is comprised of 4 letters followed by 3 digits. How many passwords are possible? So 4 letters, 3 digits. Well, how many letters are in the alphabet? Oh, there's 26. So I have 26 times 26 times 26 times 26. Now it doesn't specify that we can't use the same letter more than once, which is why all of these are 26s. And how many digits are there? Oh, there's 10. So I can go ahead and multiply all 7 of those numbers together. It gives me a really big number. 4, 5, 6, 9, 7, 6, 0, 0, 0 passwords. So what number is that? 456,976,000 passwords. That's a lot of passwords. Now let's get a little bit more specific. So a password is comprised of 5 letters followed by 2 digits. 1, 2, 3, 4, 5 letters, 2 digits. To avoid confusion between O and 0 and I and 1, the letters O and I are not used. How many passwords are possible? So now we have a limitation on the number of letters that we can use. So we can't use O and I, which means we only have 24 to choose from. It still doesn't specify that we can't repeat a letter. So instead of 26 choices, we have 24 choices. So 24, 24, 24, 24. 5 letters. So another 24. Followed by 2 digits. And we can use all of the numbers, so this is 10 and 10. So now that gives us, after I multiply it, 796262400. So 796,262,400 passwords. Alright, so that covers a lot of the problems from your final exam review. I hope this video was helpful. I apologize for all the yawning. I am a little tired, but like I said, I hope this video was helpful. Good luck studying for your final exam.